Okay, so now we're going to look at hyperbolic functions, and let's make sure you have your notes printed out. You want to make sure you do, again, memorize these derivatives and integrals, and I'll give you a better idea of, well, they're not bad to memorize, but also which ones you really need to know for your exam. Okay, alright, so the derivatives are super easy. We'll do a few derivative examples and integration examples, and then look at the hyperbolic inverse trig. Okay, so first example, find the derivative of the hyperbolic sine of x squared minus 3. Alright, so we're looking at derivative of hyperbolic sine. So it's going to be hyperbolic cosine u times u prime. So if I think about this one, u is equal to x squared minus 3. So then u prime is just 2x. Okay, so when I get this derivative, that's an equal sign. It doesn't look like it there. Sorry, I'm still getting used to our new software. Alright, so then it's going to be hyperbolic cosine, alright, of the same angle, right, times the derivative of the angle, so times u prime, and instead of writing it on the back, well, times u prime. Let me write it better right here. So the derivative would be 2x times the hyperbolic cosine of x squared minus 3. So these aren't bad. B is find the derivative of the hyperbolic secant squared of square root of x. So first of all, I'm going to rewrite this, and I'm going to write it like this so we can do a chain rule. Okay. Alright, so let's take the derivative. We're going to be looking at the derivative now. Right here. Okay. So in this case, u is the square root of x, or x to the 1/2. So u prime is just 1/2 x to the negative 1/2, or u prime is 1/2 square root of x. Okay. Alright, so let's do that chain rule then. Then the derivative would be 2 times exactly the same parentheses, and we'll go ahead and switch it back to the square root of x, but drop it by 1, so it would be first power. Alright, times the derivative of the inside. So now the derivative of the hyperbolic secant is hyperbolic secant u hyperbolic tangent u times the derivative of u, or u prime, which is 1/2 square root of x. Okay. Alright, so when you're getting ready to simplify this, alright, that 2 and that 1/2, that'll cancel out. So just a little bit cleaner way to write this is going to be, we get hyperbolic secant squared, square root of x, hyperbolic tangent, square root of x over square root of x. Okay, and then finally, I'm going to move this one over here. Let me switch real quick. Okay, so you can see this last one because I don't have room just right there. So C says f of x is equal to the natural log of the hyperbolic tangent of x squared. Okay, so u in this case is x squared, which makes du 2x. Alright, so when we take the derivative, we're taking the derivative of a natural log. So whatever's behind the natural log on the bottom, hyperbolic tangent. Okay, and then the derivative of the bottom on the top. So we're going to go back and look at the derivative of the hyperbolic tangent is hyperbolic secant squared of u times u prime. So we've got hyperbolic secant squared of u, which is x squared, times u prime, which is 2x. And I should have written u prime here just to keep the notation the same, since we're doing derivatives. Okay. Alright. And then we've got some integration examples to do. Let's look at those. Okay. Alright, I want to evaluate, I want to integrate x times hyperbolic sine of x squared. Alright, so again, we had talked about, u substitution is kind of your first thing to try, and we let u be the angle. Okay, so then du would be 2x dx, which is no big deal. So if I need to throw in that 2, I'm going to cancel it with the 1/2. So I get 1/2 integral of hyperbolic sine of u, and then I have everything I need for du. So that's what I want to integrate. So I'm looking at integrating that hyperbolic sine u, so you can see that it integrates as 1/2 hyperbolic cosine u plus c, and don't forget to switch back to x, 1/2 hyperbolic cosine of x squared plus c. Okay. E says integrate hyperbolic tangent x, and if you notice, when you look at this list of integrals right here, you don't see how to integrate hyperbolic tangent, but we know we can use an identity, and we work this one just like we do regular tangent. We're going to rewrite it as the hyperbolic sine over the hyperbolic cosine. We've done this one many a times, not the hyperbolic kind, but the regular, and we would let u be the bottom. Okay, so then the derivative of the hyperbolic cosine, you can see it right here, is hyperbolic sine. So those negatives aren't the same as they are with regular trig, so watch that. So then this is everything I need, so this becomes the integral of 1 over u du, which is equal to natural log of the absolute value of u, which is hyperbolic cosine, plus c. Alright, and then my last one, if I look, I want to integrate hyperbolic cosine, hyperbolic cosecant squared, and none of, that's not, again, that's not one of these integrals that we know. So this one I need to rewrite and figure out what I want to do. So if I think about rewriting it, I have hyperbolic cosine, right, times 1 over the hyperbolic sine squared. So I can see what I can do with this. And what I can do is I can take one of those out and then put one of them under the hyperbolic cosine. So then that's the integral of the hyperbolic cosecant, and that is hyperbolic cotangent. And if you look, here it is right here, it's negative hyperbolic cosecant plus c. Alright, and then, so those are just my regular hyperbolic functions, and then I also have the inverse hyperbolic function. So we had some notes on that, and we'll do our last two examples. And again, you just kind of want to have look at these formulas. These you do not have to memorize. For me, I will give you these formulas if you have to use it. Okay. So first one, or G, find the derivative y equal inverse hyperbolic sine of tangent x. So again, I want to look at what u and u prime are. So u in this case would be tangent x. So then u prime, the derivative of tangent, is secant squared. So, alright, I want to look at the derivative of inverse hyperbolic sine. So it's u prime on top, okay, which is secant squared x, alright, over the square root of, alright, u squared, well that would just be tangent squared, okay, plus 1. Alright. And then our very last one, when we look at it, I did it different when I first looked at it, and then my answer didn't match the back of the book. I got this one straight out of your book, and so I started looking and saying, all right, well, how can I get my answer to match theirs? Okay, so what they did is they immediately factored out a 1/3. Okay, so if you think about factoring out a 3 on the bottom, you would get 1 minus 3x squared. Okay, so they factored out that 1/3 and did this. Okay, and then you want to say, all right, well, which formula would this one match up with? Okay, as far as the integrals go, and it's going to be this one. Okay, so let's label the parts. All right, so 1 on that bottom, that 1 is a squared, so we know a is 1. Okay, but now u squared is going to be 3x squared, so then u would just be the square root of 3x. Now notice that it's the square root of 3 times x. That x is not underneath there. Okay, so there's that, which would make du be square root of 3. Okay, so I definitely don't have that, so I'm going to need to multiply that in. Okay, so I know I'm going to need a square root of 3, so I cancel it out here with square root of 3. Okay, but then everything else is good. I've got everything I need, so I'm ready to plug in to my formula. Okay, so when I get that, right, it is, if you look at it, it's 1 over 2a. So I definitely have this 1 over this 3 square root of 3. All right, let me write that better. 1 over, try again. 1 over 3 square root of 3. All right, times 1 over, it's 2a. All right, so 2a is 1. Again, all right, let me fix this. All right, 2a. Okay, then we've got natural log absolute value. All right, it's a plus u, so it would be 1 plus square root of 3x over a minus u, 1 minus square root of 3x. Okay, so let me come right here and write it. So if you multiply that, you get 1 over 6 square roots of 3 times natural log of 1 plus square root of 3x over 1 minus square root of 3x plus c. And that's, if you look in the back of the book, what they did, they have rationalized this, and they got, let's see, let me rationalize it real quick. They would have done square root of 3 over square root of 3. So they got square root of 3 over 18 natural log absolute value of 1 plus the square root of 3x over 1 minus the square root of 3x. And if you want to reverse that order and do x on the square root of 3, that's fine too. I would be okay with either one of these answers in your homework if you have one of these. If you don't rationalize it, I'm okay with that. Alright, so make sure that you do go and practice some.